Mallory Knodel will be presenting on how to think about end-to-end encryption and AI, training, processing, disclosure, and consent. Please welcome Mallory.
Thanks so much to the conference organizers. So the title of this talk and the paper is How to Think About End-to-End Encryption and AI, Training, Processing, Disclosure, and Consent. This was a group effort by PhD students and law students at NYU and Cornell. I'm Mallory Knodel. My co-presenter, Daniela Ferrari, couldn't be here. But this was co-authored by Andreas, Jacob, Betty, Derek, Sam, Kyung-Young, and Sanu. Derek and Sam are also here, so hopefully we can talk more afterwards. Our motivation for this was that end-to-end encryption has become the gold standard for securing communications, no question about that, bringing strong confidentiality and privacy guarantees to billions of users worldwide. However, the current push towards widespread integration of artificial intelligence models, including end-to-end encryption systems, raises some pretty serious security concerns, and we wanted to know what they are. 3 products we cover in the second version of the paper are Apple Intelligence, Meta AI, and Samsung AI. These tools already have the capability of processing end-to-end encrypted data, at least in certain situations. And so all 3 that we look at have this capability, but I wanted to just talk about 2 examples really quickly to set the scene. So on the left, this is the sort of notice and consent that pops up if you open WhatsApp and invoke Meta AI in a group chat setting. So people are starting to get their phones out. You can check this out for yourself if you haven't already consented to this. The screenshot on the left then is what you get on your iPhone for the entire operating system. And I think the juxtaposition here of privacy and ChatGPT is really interesting because a lot of us might have intuition these things might be incompatible, at least in the case where you're using an end-to-end encrypted product that Apple offers, such as iMessage. So our question is processing of message content by integrated AI models compatible with end-to-end encryption? And if so, to what extent, under what circumstances? So the talk outline just goes over our recommendations. We have a couple that are really based on security considerations, so training and processing. What kinds of AI integrations are compatible with end-to-end encryption is the question there. Our second 2 recommendations are more legal and normative considerations. We included legal experts and AI experts because we're admiring this problem from a lot of different perspectives. And so we take the security considerations. Given those, we are curious about what clear disclosure and meaningful consent would look like. So I'm going to walk you through each of these. So for training, this is our first recommendation. The background you need here is that models have configurable parameters, which are numerical values that determine how outputs are generated. The goal of training is to tune these parameters over many iterations in order to capture more and more patterns. Models at the scale of commercial AI assistants contain billions or even trillions of parameters trained over months. On the other hand, you have inference. So trained models are used to generate real-time responses to user inputs. One user query is processed through many steps using the model parameters to calculate an output. Continuous improvement is achieved with usually human feedback. This diagram is depicting what we are typically used to seeing in commercial AI on the left. So the yellow represents the service, which is in a cloud, and then the blue is the user's device. So what's important to note is that everything then in the yellow is off the device, which is not typically what we're comfortable with in end-to-end encryption. The end-ness is quite important. So you'll notice the model as well as chat logs, data storage, the training happens, and then the metadata is also all in the cloud. This is again typical, right? But if you looked at a local architecture, all of this then moves on to the user's device. But this includes the model, this includes the training and the processing, which for a lot of end user devices could be pretty challenging from a computational perspective, right? So this leads us to our first recommendation. It's on training. It is impossible. There is no way that we found in our analysis to use end-to-end encrypted content to train a shared AI model in a way that is compatible with the confidentiality and privacy guarantees of end-to-end encryption. And by shared AI model, what we mean is a model that may be used for inference by multiple users, or may be trained on multiple users' queries, which is these sort of commercial AI assistants at their very heart. So moving on to the second recommendation, we need to introduce an additional piece of background here. We are not going to cover encryption for this audience, but we do want to invoke a little bit more about what this cloud-based processing and training would look like, and most notably, private cloud computing and other things have been suggested. So we wanted to compare then these trusted hardware goals against the end-to-end encryption goals. Now, I do want to state, privacy against third parties, integrity and tamper resistance are definitely goals of both. But end-to-end encryption and trusted execution environments have different, orthogonal, and incomparable security guarantees. So we try to show that in the slide. They're just not the same thing. I think that's the major takeaway from our analysis. And we did actually look at other privacy enhancing technologies besides TEEs, although there have been no big papers or schemes that have suggested you could do this on with commercial AI assistants in encrypted messaging apps. So but we did go through them, right? So we have this evaluation framework, an analysis that looks at these different potential architectures. Maybe we start at the bottom and you can see, server-side plain text inference it's not going to work. It's the most vulnerable. All the way at the top, you have potentially an on-device model that's locally fine-tuned, or maybe you have some server-side interference that uses fully homomorphic encryption, like that could also not be super objectionable. But we did notice that some of the things we looked at that are real proposals out in the world fall into this not compatible bucket. This is our second recommendation now, and it's a bit lengthy because it's got a lot of nuance. So processing end-to-end encrypted content for AI features, both inference and training, could be compatible or may be compatible with end-to-end encryption, but only if the following recommendations are upheld. So you want to prioritize endpoint local processing whenever possible. And if processing end-to-end encrypted content for non-endpoint local models, then no third party can see or use any end-to-end encrypted content without breaking encryption. And a user's end-to-end encrypted content is exclusively used to fulfill that user's request at that time and no more. By this, we mean content is not just the message itself, but any derivative, non-trivial function of that content. And then what we mean by breaking encryption, you could do this without breaking encryption with some privacy-preserving technical configurations like FHE. So I'm going to transition now to the last two recommendations, which are if you recall, the legal and normative recommendations. We felt that the security considerations implied that we needed to look at this problem from this angle as well. So in the paper, there are 4 main areas of law that affect how messaging services can be regulated for privacy-related obligations: contract law, consumer protection, data protection, and antitrust. I'm going to focus mainly on the first 3 areas, which are more directly related to our focus. So one thing that these areas of law have in common is the reliance on user consent as an important part of how companies can justify collecting and using user data. So in the US, the notice and choice or notice and consent model is the dominant framework for how the law treats online consent. It's seen as a two-way stream where digital services like messaging apps would give users some form of notice or disclosure of their terms, typically in a privacy policy or terms of service agreements. And users will consent to these terms by signing up and providing their information. They click on an I agree button or that sort, or they just continue to use the website, right? There are these critiques though. One, consumers do not read privacy policies or terms of service. Two, company data practices and privacy harms are hard to understand. Three, there are limited alternatives. If you say no to using one website, where do you go? Four, user preference may change over time and could vary according to the context. And the last one, individual consent does not capture well in group settings. But despite all these critiques, that consent is really a fiction, the fact is these asymmetric contracts determined by the companies are still legally valid and enforceable in the legal landscape. So what does this mean? I mean, our interpretation and then is that contract law likely can't do much to protect consumers. So what's a more promising way to hold companies accountable to consumers? In the US, it's consumer protection law. The Federal Trade Commission, known as the FTC, is the federal agency that investigates unfair or deceptive company practices. The FTC can investigate security-related incidents as deceptive practices, and the focus is on the disclosures and whether the company's statements are misleading to consumers. There's a good case here. In 2020, the increased use of Zoom by consumers during the pandemic led to the discovery that Zoom was not protecting all video calls with the end-to-end 256-bit encryption that it was advertising. So this and other FTC cases have marked precedents that if a service is marked as using end-to-end encryption, the service must implement it throughout the processing of the data on by default and has to meet industry standards for what is end-to-end encryption. So, another promising way to regulate companies Europe has found is through data protection law. This generally sets rules for the handling of personal data. The US doesn't have a data protection law for consumer privacy at the federal level, even though more and more states are adopting this. Most of them that we've seen are reinforcing the notice and consent model, and they focus overly on opt-out. So talking about Europe, it's more robust data protection landscape, and the GDPR is the most prominent law here. GDPR goes beyond notice and consent. It imposes broader data obligations on companies that offer services to people located in the EU. For example, companies need to have a legal basis for the processing of any personal data. User consent can be a legal basis, but needs to be shown by an affirmative act of acceptance, such as by clicking a button. There are other EU laws beyond the GDPR that touch on regulation of personal data and opt-in consent. So the e-privacy directive regulates the confidentiality of electronic communications and requires opt-in consent for storing or accessing information on a user's terminal equipment. The Digital Markets Act regulates competition and requires opt-in consent for merging data between a company's different products and services. There's also the EU AI Act that's recently reinforced the GDPR and the e-privacy directive's application in the context of AI systems. It's a complex web of regulations. And there's some ongoing controversies. So the EU's data protection regime now applying to AI models, there's some ongoing debate about how this is going to happen. But for the first time, EU regulators have begun investigating whether AI developers are actually complying with the GDPR when they're training AI models on personal data. So one is the Irish regulator questioned Meta for updating its privacy policy to allow for AI training on public data, mentioning issues related to user consent. But so far, the investigated AI models have been training on publicly available data. If AI models start training on private user messages or end-to-end encrypted content, and in the paper we discuss maybe some incentives and reason why that's, I don't know about inevitable, but definitely headed in that direction, this would likely raise far more concerns and legal questions related to user consent. So this is our third recommendation, our first of the norms recommendations, that messaging providers should not make unqualified representations that they provide end-to-end encryption if the default for any conversation is that end-to-end encrypted content is used, either for inference or training by any third party. And then the fourth one is related to the consent feature, and obviously disclosure and consent are very interrelated. Here is a well-implemented consent interface can make a really important difference. Users should be able to consent specifically to add-on features such as AI assistance and the very many ways that they can be invoked differently and in different contexts. And they need to provide a clear and easy to find opt-out mechanism. It shouldn't just be once and forever for all features all the time. So just to go back over again, we talked through these 4 recommendations that all kind of work together. We're really trying to speak to folks who might be thinking about implementing these features and try to help come down on the side of encryption, right? That was the sort of, hopefully, conclusions that you can draw from ours. Again, this is what we set out to, the central question we set out to talk about. There's a whole lot more in the paper. There's some really interesting discussion sections about how this maybe relates to the crypto wars and things like that, as this continues to unfold with more and more products coming out. This prompt was, create an image of AI assistant reading private user messages. Delightful, right? We also wanted to end really quickly with things that users can do. So there are some, I think some things to pay attention to. Again, this is changing rapidly, but you can pay attention to the operating system level app permissions first. You can also then go into the apps themselves and review settings there. As it's always true, as we heard a lot this week, be aware of what you're sharing and to whom. Don't assume that everything is okay just because it's an end-to-end encrypted app. Things might have shifted. I screen cap opt-in of any kind, right? Because it's sometimes hard to find that screen again. So make sure if you are opting into something, you know what you're opting into, and figure out how to opt out, right? As with any confidential communication that you're really concerned about, it's probably important to just be upfront and talk to your contacts about it. Not always is the consent going to go in every direction. So someone you're talking with might have enabled these features and you haven't. So how does that impact your privacy? Just ask. And then I think it's important to raise our voices about why we care about privacy features. I think there's a perception that these convenient AI features are more important or better, or people like them more. And so I think we need to, because they can be somewhat paradoxical, I think we need to talk about what we prefer and what we really care about. So that's the end of my talk. You can find the paper at this QR code link. And just for fun, there's another AI generated image. So yeah, thanks.
So in recommendation 2, if you can just go back to that slide, says a user's E2EE content is exclusively used to fulfill that user's requests, and then you added verbally at that time. So, for example, if a user deletes data that was previously used to train an AI model, should the recommendation also include deleting the effect of the data on the AI model? I know that may be very difficult, but it seems to me that that's a user would not expect the AI model to then be able to reproduce that data that the user hasn't explicitly consented to be reproduced.
I can see where you're going with this, and I think we agree, and I think we have talked about how removal of data from a trained AI model is really challenging. So we break that down in the paper. And of course, we're trying to be as practical as possible with this. So it's not in the recommendation itself, but I'm guessing you'll find what you're looking for in the sort of rest of the paper where we talk
Thank you.
about this. Yeah.
It's helpful that we're on this slide. So here you acknowledge that using things like FHE, or I would argue multi-party computation as well, can make processing compatible with E2EE. What I don't understand is why that's not true for training, or perhaps in what way training isn't just like a special case of processing.
Right, so we go into this and it's again, because it's a shared model. So, I mean, you could potentially have that whole model on your own device and then there's not an issue. But if you're training a huge shared model like this, it doesn't seem to us that there's any way to get around that data, just as the previous question was coming back out again. And then we go into detail about why this is, but this recommendation 1 by far was our strongest recommendation. It just seemed to us that there was really no way around this. We wanted to make as strong recommendation as possible.
Thank you.
Some questions.
Cool.
All right,
Thanks.
let's thank our speaker again.